All right. Hello. Welcome back. Previously we went through how to set up Kick Assembler and how to get this little test code working. And lately I've been thinking about starting up another channel where I wanted to do some gaming and things like that. And to that extent, I figured I would need some kind of intro or something. And in that particular case, it would be pretty cool to code that intro on the Commodore. And so I figure, okay, I'll make a continuation of the first two episodes. And I have to admit, I have started a little bit before I came up. Maybe I should, record it because it could be interesting for somebody. The point is that some of the code is done, and this is what we did the last time, which basically just changed the screen to the black color and cleared the screen with this ROM clear screen routine. So, but we're done with that, and instead here is the code as far as I've gotten it right now. And since I came up with the idea after I started, I've already done some of it. So I thought I'll just go through the code that I've done so far and show you what it looks like. And I have some things remaining, and I'm also thinking of making an end screen with the up scroller thingy. So I'll try to document that, and just for the fun of it. Some of the things I'll be talking about, I cannot go into very deep detail because it will just simply take too much time. So if there is questions and things like that, feel free to post it. And if there is things that many people are wondering about, I might consider making some designated videos about it. So just let me know. Anything goes in regards to programming on this fantastic computer. So the channel that I wanted to make is, I plan to call it TWW Gaming from my handle. TWW is basically my initials for my name, so it's not very, ironically enough, creative. Now, the first thing I did was to make a logo, so I'll show you the logo. Here we go. Oh god, that's horrible. I'll open it in Paint. There we go. So here is the logo that I drew, and I actually drew it in Paint, so you don't need any. And let me be clear, I'm not a graphician or anything, graphics designer or anything like that, as you can see. This is very old school style type of logo, and it's, just for the fun of it. It's supposed to be a little bit old school. Now, mayhaps in the future I might change this out if somebody who has some skills would like to make another one, then I'll be happy to update that later. But for now, this is just to have some mock-up and get the thing working. And the thing to note here is that it's made in multicolor, and it uses 3 colors plus background. The background color is the black color, and then you have white and medium gray and dark gray. 3 colors. The reason why I use only 3 colors is because that's the limitation that you can use in multicolor character sets. There are ways around it, but for now, just accept it's how it is. The more complex ways to do that and handle even single color and multicolor at the same time, there are tricks to do that, but it's not actually tricks, it's actually functions of the graphics chip. But for now, the idea is not to code anything that is going to win any new demo competition or anything. It's just to make a simple intro. So this is what it looks like. And the interesting part here is the size. As you can see down here, it's 848 by 96 pixels. It's fully dividable by 8. Now the character set is basically made up by 8 by 8 pixel block. Now a pixel block here, let's say that's 8 by 8. So that is one character. This would form an A if it was on a regular character set. However, in multicolor mode, you are limited to only 4 pixels and not 8 pixels in the X direction. You have 8 in the Y, but you will only have 4 pixels, which are twice as big in the X direction. The reason for this is quite simply put. You need 2 bits to determine which of the 4 colors, background, white, medium or light, dark gray, that you should use. So 0, 0, background 0, 1, and 1, 0, and 1, 1, the 3 other colors. So 2 pixels, 2 pixels to determine which of the 4 colors that should be used. So that's how it's set up. So that's the logo. Now, another thing to note is that there is a limitation on the graphics chip. You can only have as many as 256 characters in one character set. But that doesn't mean that you cannot have multiple character sets. So, for example, this logo, it contains too much unique 8 by 8 blocks to fit inside 256 characters. So to get around that, what I basically have done is I just split it somewhere in the middle here, and I make one character set for the top and one character set for the bottom, and then you can get it to work. Now, why use character sets instead of bitmap? Quite simple. With bitmap, you will have the option of more colors, and it is doable, but it's going to be a little bit heavier and more CPU intensive, actually a bit fully CPU intensive. The simple reason is when you move 8 by 8 block like this in bitmap, if you want to move this one from here to that location, if you're moving this in X direction or Y direction or whatever, in bitmap you're going to have to move 8 bytes just to move all the bitmap graphics to this location, and in addition you're going to have to move the color information in that block, which is both the character set and the color attribute, which is actually 2 more bytes. So it's 10 bytes you have to move per 8 by 8 pixel block. In character mode, you don't need to worry about the colors because there's only 3 in their set, so that takes care of itself. So you only have to move 1 byte. So it's 10% basically of the CPU power to move that around on the screen compared to actually moving heavy bitmap. You could use bitmap and not colors, just keep the colors static. So, but you still, it will be 8 bytes. So it's a lot more CPU intensive. All right, there are a lot of information of these things if you want to learn more about it. So the 12 top lines, 12 lines, since it's 96 pixels, 96 divided by 8 is 12, which gives you 13 lines below it that I plan to use for some text. And the text will consist of a 3 by 3 character set. I'll come back to that a little later, but spaced out like that. So onto the actual code itself. Now, I start off here by importing some source code from a file called library. Here I have a lot of library things which allows me to reuse code and things like that. So every time I do that, I'll take a look and show you what I'm doing. Then I put inside some information about the logo. So the size of pixels in X, the size of characters in X, which is basically that divided by 8. Same for Y, and then also where I split it. So 56 pixels on the top and 40 pixels on the bottom is where I actually split up the two character sets. And then I have to create a character map for the upper and the lower part. And I need some character sets, and I need to also define where the screen memory should be, which I'm just going to use the basic 400 hex address. So that's quite straightforward. I can quickly show you. Don't I have some, yeah, the test code here. Let's change that. So let's just make it white text color. And so basically what I'm doing now is the same black screen, make the text color white and put the value 1 at memory location 400, which is the screen memory. So if, there we go, the A comes up on top because the value for A is 1. If I were to make this 2, it should be a B. There we go. So that's exactly what I'm planning to do here. So, but I need to fetch the graphics from this PNG file and convert it into character data that I can use. So I'll show you how that works a little bit later. So we have that, we have the memory locations, also the character set. As I said, we'll come back to that. That will probably be next time. For now, I'm just going to go through the code so far. And this part here is actually what converts this logo into usable data for the C64. So I start off by defining the equal CharPad palette. The equal CharPad, let me find that for you here. It's part of the library. Macros and that one. So this is the equal CharPad script. I need to make sure this comes in the right color every time, but okay, I'll fix that. So anyway, this was originally made by Cruiser of Camelot, and I've made some modifications to it. And basically what I do is, this is script language, which is the advantage of Kick Assembler, which was the whole point of going through that exercise. So basically, if the equal CharPad palette is defined, which is what I'm doing here, define it, then the macro equal CharPad should also contain this palette value, and also the variable pic, which is just a variable picture, which is load the picture, which is the file name that I tell him to convert, and also include the palette data. And if it's not defined, okay, never mind the palette in both the CharPad and the pic. So that's it. So I'll just distinguish, but since, especially since I use 2 character sets, and you would, for the most part, want to control which color attribute is connected to background color, what is connected to the character color and what is connected to the two multicolor colors. And by doing it this way, I can control that. So I define that, and then I define these colors that is used. And this is from the logo. So if I fetch, for example, this gray color here, this is actually new. So how do I do that? Is it that? Yes. So I can click that button. Before it was an edit button. This is Windows 11 fancy schmancy things. So anyway. So here you have the RGB values, red, green, and blue, right? And 127 for this one, which is then defined here, 127. Then we have the white and the black, and then it's the light gray or medium gray. So we have defined the colors that is used in the logo, and this has to match. If not, it's gonna not work. And you cannot use more than 3 colors, and you have to make sure that the layout is correct with double pixeling for multicolor. For single color, you just use 2 colors, and you can use any other pixel, that's fine. But for this, you have to be very precise about this. And then I create a variable which I call equal CharPad palette, which consists of a list, which is basically these colors. And the order I put these colors into this list will determine which attribute it is connected. So I can change this around to make the colors pop up on different places. And then I will just equal CharPad the upper part, and then it will be set to the memory location for the upper area. This is the map, the actual layout of it, and also the character sets, which is located to 2000, and then it uses the palette, which is defined up there. And then you do the same for the lower part, and that's it. This will convert this logo into usable data. Now, what happens here after that's done, this is also documented on code base, or at least you will find the source code before I modify it. But basically, you create a map with a hash table which contains some keys which identifies if a certain combination of bytes have been used before or not. And then you just keep on creating or adding to a list the new unique combinations of 8 bytes per block until you're done with the logo. And that's basically handled. This is the modification. It's actually taking care of different size logos, not just a standard 320 single color pixel wide logo. And then it's a loop for each Y line, and then again for each X line. And then it just starts reading this data. I have some comments here explaining it, add it into the lists, and then in the end it just fills the data from these lists. And there you have it. It's just spewed straight into memory. It's really the beauty of this script language. I'm not going to get into all of this, but take a screenshot and you can read through it. And all these functions and things are documented in the Kick Assembler manual as well. So it should be doable. And for those of you who program in some other languages, it should be mostly familiar. So that's that. And it's very easy to reuse once you have it and it's part of your library. You can just use it. It's very easy. Next time you don't have to rewrite that. You can just use the same snippet. All right, here's a variable x that I'm just using for typical loops and stuff. So not specifically intended for something, just a variable. And here is a built-in function of kick assembler, which is the basic upstart 2, which allows me to call the main program. This thing will just basically add a sys command in basic, so when you run this, it will start the code. You don't have to type in SIS and whatever address, 4096 or whatever it is, 2064, yeah, God remember all these numbers. And then the main code starts here. And then this you maybe recognize. This is telling you the background color and screen color, which is 0, which is black. And then this color here and that one, this is also setting 2 colors. You can see it's continuing from here. This is the 2 multicolor colors. 3, that's cyan, which is some sort of very light colored blue. And the 0E is light blue, light color blue. Now this part is a loop that is basically a clear screen and set the color for the characters. So the screen consists of 40 by 25 characters. So you multiply that out, you get 1,000 characters. So in order, this is completely unnecessary. It's just I like to do it like that. So basically I use the index register X, load it up with 250 and 20. That is the Petsky code for a space. So that's I want to just fill the screen with space. And I write this to the screen mem. I could have done it like this in case I change that later. So I'll do that now just for the fun of it. Because you can define this to be any, well, not any, but you can change it to many different places where you want to keep it, the screen memory. And now I only need to change that here, and it will update throughout the program, which is also nice. And then I'll take this space, I'll write it to the logo screen memory, plus this is unnecessary because it's multiplied with 0, so you can forget about that. And then this strange -1 here. And then it will add whatever is in the X register. So it will write it to the logo screen memory, -1 plus 250. So it will be effectively plus 249. And then here it will be plus 499 and 749 and 999. 999 is coincidentally the last character in the bottom right screen, and 0 is the top left one. And then I will choose color 0E, and this address will never change. This is the color memory for the screen. So that's fixed. You cannot move it, so no point to put any variable here. Basically does the same. 0E, and this is where character multicolor graphics become really messed up. Because here I told you it is light blue, but this is actually dark blue, and it makes no sense. But you have to subtract 8 from this, and then you get 06, which is the code for blue. Now if I put this to 06 instead of 0E, it will actually become single color in blue, dark blue. I have to put it to 0E in order for the multicolor function to work, and even if it's 0E, it will you can deduct 8 and you will have the only access for this particular color for the 8 first colors, which is black, white, cyan, purple, green, blue, and yellow. I hope I didn't forget one. So anyway, we can play around with that later. And then I will decrease X with 1, and I will check if it's equal to 0 or not. If it's not equal to 0, okay, do it again. And he just branches back, and then he next time is 998, and he'll do that for each block of 250 bytes until this one is 1. So when the X is 1, it will be to the logo screen mem -1 plus 1, which is 0, And then when he decreases from 1 to 0 here, he will not execute the branch, and you have effectively filled up the screen without any comparing x to whatever value. Or yeah, so I think this is a neat way to do it. You could put this to 100 and add more lines here, and then you could do 10 lines, for example, and then just change this value to 100. There's no problem at all. That would make it execute a little faster because you would only loop 100 times instead of 250 times. But this is in the initial setup, so it doesn't really matter. It's just yeah, force of habit, I guess. So there you have it. The basic setup is done. We have cleared the screen. We have colorized it the way we want it, and okay, we're ready to start the part that will handle the actual logo and displaying things and splitting the screen and these things. And this part can definitely be a little heavy if you're not used to how these things work, but I'll go through it. So the first thing we want to do is tell the computer to stop interrupting, basically. Set interrupt flag, which will prevent interrupts from happening in the ROM code. So when you start the computer, the ROM is flashing the cursor and it's checking what you're doing, etc. It will stop doing that, and you are in control. The next thing I'm doing here is I'm writing the value 35, hex value 35, to the CPU I/O register, and that basically controls what memory configuration that you're currently having. And the CPU itself is only capable of addressing 16 bits, so you can only address 64 kilobytes of memory. And in order to address more, you need to do effectively bank switching. So this particular code will disable the basic ROM. I don't need that. And it will disable the kernel ROM, which I also don't need. I'll take care of all the code myself. I don't need that, and that makes that RAM available for me to use. And that's okay. The next thing is this one, and as you can see, this looks a bit strange. So here is another functionality of the kick assembler, which I like. So this is just an abbreviation. It's a 16-bit read and write that I do, move 16. And it fetches the low byte and high byte value of the label IRQ1, and it writes it into memory address FFFE and FFFF. If I were to do this conventionally, I would have to write this as like that. There we go. So this is the same as this. It just shortens the code. When it's compiled and it's output, it will look like this. Now, how is that handled then? Well, then we have to go down a little bit here. So here is a sudo command. This is again a kick assembler functionality, where I define move16 as a basically it's a new OP command, and it passes two parameters, source and target. So it fetches here, it just fetches from source and store to the target, and here it fetches the 16-bit argument of the source and store it to the 16-bit argument target. The 16-bit argument, that is a function which is defined here. This stuff is documented in the kick assembler manual. It's copy-paste from there basically. But you can expand this to handle compares or add or subtract 16s and things like that, you know. So it's just a convenient way to handle 16-bit values. And basically this 16-bit is just uses one argument, and if it's immediate value, it will return the value of the argument from the function, which then will be based on whatever address, or in this case the source and target here, and that will generate the correct values. However, you have to be careful because where were we? Here. You see here I define this as a value, a hex. This is an address and this is an value. If I remove this, it will actually fetch the address itself and not the low and high byte of the actual address. It would mess it up. So this is how that has to be. Now, what does this do? Well, the IRQ, that is this label here, which is where I want my interrupt code to run. And I'm telling the computer this FFFE and FFFF, that is the value or the location where the IRQ vector is stored, jump vector. So when an IRQ happens, IRQ interrupt, for some reason, the computer will, or the CPU will look at this address, and whatever address is stored there in low byte, high byte format, it will jump to and start executing the code. So with that defined, the next thing that I want to do is to make sure that only the IRQ interrupt that I am telling it to happen should happen. And the first thing I want to do is turn off the interrupts that are generated from the CIA chips, which is a keyboard and disk controller and these things. And this is a bit strange, but 7F, that is basically so this is 7F in binary. Now it's 7, if you can imagine, 7 potential sources of an interrupt, and this is the control bit. Now I set this to 0, it means turn off the following interrupts. So turn off the following interrupt. If I want to turn them on, I will put this to a 1. If I wanted to turn them on except that one, I'll put that to a 0 and so on. So that's basically how that works. But now I'm turning off all interrupts from CIA1 and CIA2. And then I acknowledge if there's any pending interrupts, which normally shouldn't be. Well, it could be from this one, but either way, by doing that, it will be acknowledged. This is just how you acknowledge an interrupt, telling it that, okay, clear it and wait for the next one. But there will not be a next one because you already disabled it. And that's it. We are done with the CIA. No need to worry about that anymore. This part, it's probably the most important part of this. The first thing, the D011, it controls many things. But for this purpose here, one of the bits on the D011 actually controls when an interrupt will happen based on a raster interrupt. You can imagine that the raster interrupt counter runs from 0 to 255. However, the screen, the size of the screen has more than 255 lines. So the corresponding bit here, controlling if it's supposed to be triggered on the upper or lower part of the screen. So if this is set, it will trigger on the lower part, and if it's clear, it's triggered on the upper part. And for this, I want it to be triggered on the upper part. 1B is the default setting. It also controls things like vertical shift register, hardware scrolling in Y direction, up and down, and it controls blanking the screen on and off, and it's also controls if you're displaying bitmap or regular character sets. Right, so the next one here, that actually tells you which of the 252 lines should be triggering the interrupt. And in this case, I want it to happen on line 32. Line 32, that happens to be the top line on the screen. 0 is totally on top of the screen, but then there is the upper border, and 32, that's the line where the actual text screen starts to be displayed. So I'm telling the VIC chip, the video chip, trigger an interrupt when you come to line 32 on the upper screen. That's what I'm telling him. Next thing I do, turn on interrupts. So this here is a little bit simpler. Here you just put a 0 or a 1 on whatever bit you want to actually trigger a VIC interrupt. You have interrupts from the raster, which is based on these two values, and you have interrupts from sprite collisions, and you have interrupts from this light gun thingy that used to be popular in the 80s. But in this case, I'm only interested in the first, which is the raster interrupt. So turn off all the other ones, 0, and turn on the VIC interrupt. I'll write that to the control register for interrupts on the VIC. And then also I write 01 to D019, which actually acknowledged if there is any pending interrupts. Now, with all this set up, so turn off the ROM, tell the computer where to execute code so that it will fetch the address, indirect jump to the address at this location and start execute when an interrupt happens and it's allowed to execute them. I turn off then acknowledge any CIAs. I tell them where to trigger a raster interrupt. I enable the raster interrupt, and I acknowledge any pending interrupt. Why do I acknowledge pending? Well, if let's say one triggered, then exactly at this point, as soon as I allow interrupts to happen again, it will actually trigger immediately. So I want to make sure that I acknowledge it, and then I clear the interrupt flag, which means, okay, you're allowed to let interrupts happen from this point. And then I just jump to myself. It just goes into a eternal loop, and it will stay there until something happens. Now the ROM code is disabled, the basic is disabled. Then the only thing that's going to happen now is as soon as you reach this point on the screen, an interrupt will trigger. He will fetch the address from here, which happens to be this one, that address, and he will jump to this location and start running this code here. So this code, this is then from the first line on the text screen. Same here, 1B, and here I do it because I want to make sure it's character mode, and also to control where the next IRQ should happen. And then here I have a value of 18 written to the DO16 VIC register, which controls the multicolor mode of characters and also bitmap. And it also controls the horizontal shift register. So yes, horizontal X direction, that is correct. This one, D018, controls where should the VIC get its graphics data from. Now 18, that corresponds to this memory location, which is 2000. So the character set here should be fetched from 2000, which is where the character set is, and 0400 is where the screen memory is. So that is the meaning of that value. It's possible to um, use the values on top, and maybe I'll change that a little later. I have a small script for it, which is automates that for you as well. There are some of the bits here which controls these things. And then here I'm telling when the next interrupt should happen, and it's basically it's 32, which is the top screen, plus 8 times 7. Remember, the upper part of the logo is 7 lines big, so 8 because it's 8 pixels, and I write that to D012. I acknowledge the interrupt. I tell the computer when the next interrupt happens, which is here, where to jump, which is at this location. This location here, this will start to happen. Normally you would preserve the A, X and Y registers and things like that, entering and exiting this IRQ code things. But since I'm only doing a jump here, not doing anything else when the interrupts are not running, there's no point really, so there's no need. This is a delay. It just loads the X register with 8, it deducts it to 1, and it branches until it equals 0. So this is just a small delay. It's a timing delay to control when, where on this line he should start doing this. So it's a bit finicky, because if I put this to +1 here, it will be too late. So I have to do that and then push it to get the raster beam where I want it, and then make the changes. So what I'm doing here is I'm instead of 18, I'm writing 1A. 1A, that actually is the location of the other character set for the lower part, which is 2800. And then I tell him, okay, when do I want the next interrupt to happen, which is then 12 lines down. So that's after the logo is done. AC and next interrupt. And here's the last one. Again, some timing. And this time, this value has changed. Instead of 1B, it's now gone to 3B. And 3B, that actually enables bitmap mode, which I'll show you in a moment what it looks like. I put it to single color, so instead of 18, it's 08. Oh, and one thing I forgot to mention here. This part here, SMC, is self-modifying code, D16. So this actually is, this value here will change depending on the scrolling of the logo. So it's just how I like to write it. We'll see that later. So there we go, 32, that's when the next interrupt should happen. The 3B also is for the upper screen, so that's no problem. And then here I have a subroutine, which I am calling after. And it's important to remember where you call this. And I don't want to call the actual movement of this logo when you are drawing it. I'll show you soon what that means, but that will make it buggy as hell. So anyway, and then I started on the text routine, but will not do that now. I acknowledge, and then I tell him to actually go back to IRQ1. I'm done. So then he goes back up here. Next IRQ, he will start from the top again. And that's it. The size of the logo is bigger than the screen, so in order to show it, I have to swing it back and forth. So here is the code for that. Here is the subroutine. It's called from this location. It's not a big routine actually. So it gets the character sign value, which is basically the value of which 8 pixel position the logo should be in. And then I have another sign value, which is for the D16 values, which is the soft scroll values. And if the value read from this is 0, which it will never be if it's a legal value, because then it will be single color first of all. Well, actually that is it, and it's multicolor. So I'm just using a value of 0, and if it's 0, then jump up here, reset these self-modifying code pointers to where these are located in memory. So then he fetches the value of the memory location and he stores it in this, so it resets. This part here will increase it. So this will just keep counting upwards until it reaches 0, and then it will be reset. The D16 will be written to SMC D16, which was the value up in the IRQ, which controls the soft scroll, hardware scrolling. And then this part here is actually what displays the logo on the screen. So it uses a loop for the upper and a loop for the lower. And it's a for loop. And here is when you see the X value used finally. It has to be defined before you can use it. So it's as long as the X is less than the logo. Does it say 6? It should be size. Wow, okay, looks. That's cool. All right, so it should be size, and that should be also from up here. Yes, okay. I'll fix that later. Not terribly important. And increase X until that condition here is true. And then inside these brackets, this is what he will put out. So fetch from the logo map on the upper screen plus the X value, which is fetched from that, multiply with the size of the logo in X. And then write that to the screen memory plus X times 40. 40 characters of one line. So for this is the first time X is 0, then this will be 0. Next time it will be 1, it will be X is 40, it will draw on the second line, third line, and so on. And then basically you do the same for the lower part. Increase the value of X, increase the value of Y, and check if the X value equals 27, which is the hexadecimal value for 39, which basically will just do it for all the characters. This will create a lot of LDA, SDAs, LDA, SDAs. So it's just a little easier way to write it than having to write 1,000 lines of this thing. And then I increase the pointers, and then that's it, done. And that's it. And then I have the sinus values. This is the D16 sinus values. Fill 256 bytes with the width of the sinus plus the width of the sinus multiplied with sinus. Convert to radians. When you use the fill command, it's creating a loop with a variable I that you can use to multiply. Then convert from 360 to 256. And then up it to the power of 7, and then you AND it with 7, because I'm only interested in the 3 last bits, and then I OR 10 to it, which will add multicolor. So this is the 3 least significant bits that control the X smooth scrolling. And then this will create multicolor. And here is the byte 00. So after it's done filling that, I will put a byte of 0, which tells him, okay, that's it, so reset and start over again. And the width of the sign depends on the size of the logo. So I just enter the size, and then the speed of it, I can change that to more 512, for example. And it will move slower but smoother, and if I do less it will be faster. So it's quite easy to adjust how you want it to look. And for a character set, It's same calculation for the sign values, and I just right shift it by 3 to, and the 3 right shifts is actually what then is used here for the soft scroll. So those 3 will be defined here, and this will be basically the character positions. And that's it. It's quite simple. Now, let's hope I didn't mess something up. I'll try to show you what this looks like. There we go. So, the logo here is moving according to the sign value that is defined here. That seems to be working fine. You cannot see the splits or anything. Now I'm not sure how this is going to look on the recording. This is, I believe, 50 Hertz. So what I'm planning to do is I'll try to write this to NTSC and with 60 Hertz, so it's easier to get smooth movement in the final once it's done. And on the lower part here, this is actually Bitmap graphics from, if I remember correctly, let's see. Yeah, from the regular character ROM location. So this is the basic characters. Now why I'm using Bitmap here in the bottom is because the character set that I'm planning to use, let me see if I can fetch that for you. I use this tool, CharPad. It is very, very nice. There we go. So here's the character set that I was planning to use. Now it's based on a 3x3 characters, and here is the actual character set map, which contains all the letters. I used this char set in a intro or a graphics demo some years ago, but it will do for now. I might change it later, but anyway, so here is the actual character set, and you can see the quantity of characters is 864. We cannot have more than 256. I can't compress it, and it just brings it down to 362. If I could compress it to 256, then I could use this tile set to display it correctly, because you recycle characters that has been used before. So that's not going to work here. So that's why instead of complicating this anymore, I'm just going to use the character set as it is, and instead of writing it out as a character set, I will plot it out on a bitmap screen instead. So that's the reason why there is bitmap on this lower part. Now I did start to write a little bit on it, and this is just how the layout is from the CharPad. So and there are some special characters M, W, and this Norwegian letter A, and I'm just writing in there where to find it. Now the idea is that I want to write the text line, and I want it to auto center, and that's something that I will probably use for the up scroller as well, that I will use for the end part. And this is as far as I've gotten on this. We'll pick this up on the next episode, but basically what is done so far is this is just resetting some variables, write 0 to them, and then it fetches text line 1, which I got down here somewhere. Here, text line 1, so testing. And since each letter, the I is shorter than the T, for example, and the W is longer, and I have the width table here, which defines each character, how many, what the actual size is. So I'll fetch the text line 1, check if it's FF, that means it's done, And if it's equal to FF, then it's done, and it will continue from here. If not, it will use the index from the value, and from the width table get the actual size, add it to the width counter on line 1, which we reset up here, and we'll increase this pointer here to fetch the next value, and we'll jump back to here. Now, I'm not loving this way of doing it, but it's just how far I'm gotten from now. Basically, it's an eternal jump here, and you're waiting for a condition to do a branch, and if for some reason that doesn't happen, you're stuck in an eternal loop. So, but anyway, it works because I have control over the FF byte here. And then yeah, this one here is not really necessary, but basically I take the width of the screen and I subtract the size here, and then I divide that by 2 by shifting it to the right. It will cause a rounding error because you can't do a half one, but that's fine, we'll live with that. And then I have the offset. So after he has calculated the width of this line, he takes the width of the size, subtract the width of the text, and then that gives you how much free space there is, and you divide that space by 2, you have it centered. And then the next thing now is to actually print this, but I'll pick that up in the next episode. And I know this was a horrible lot of information, and for those of you who is not familiar with this type of programming, it will probably be damn near impossible to follow. But I've been doing this since the 80s, so it's a lot of these things are by memory, and some things I have to look up still. But if there are specific questions or things that you want me to maybe even go in depth on and look at, sure, I'm definitely up for that. So please let me know, and then next time we'll actually do a little bit more actual coding and not just looking at it. So we'll pick this up next time. We'll try to get this text to show on the screen, and then I'll show you the process on how to get it done and how to get data from here into here. Okay, so thanks for watching, and hope you enjoyed a little bit, even though this, for those of you who might be watching who are seniors in this game, this is completely low level, and but hey, that's how it is. So this video was honestly not intended for you guys. So for you guys, the pros, go schmeg yourself, and for the rest of you, happy coding, and feel free to let me know if there's anything you'd like to see. Take care, and code your asses off. Cheers.